Alrighty, so for this problem, we have to find the curvature of r of t at the point 1, 0, 0, right? The easiest formula to use here in this case would be k is equal to the magnitude of r prime of t cross r double prime of t over magnitude of r prime of t cubed. That's the formula for the curvature. Um, One of the quick things that I want to notice or I want to talk about is the fact that given this information, we can actually find what t value it is that gives us this exact point, right? And that t value would actually be equal to 1. And you can verify it for yourself. You plug in a 1 here, you get 1, and you plug in a 1, ln of 1 is equal to 0, and this is a t, not a plus sign, just to make sure. But you have 1 times ln of 1, which is 0, so it's still 0, so we still get the point 1, 0, 0. So our first task is to find r prime of t. So we just take the derivative of that. Pretty simple. It's just going to be 2t ln of t ln of t, right? And then t ln of t is just a simple product rule. So ln of oops, sorry, I just kind of rewrote that. That should be 1 over t. Sorry about that. And then this ln of t is just product rule. You'll just get 1 plus 1 there. Okay. So this is our derivative, our prime of t, and we want to find our double prime of t. R double prime of t, right? And that's just going to be equal to 2, right? Negative 1 over t squared, right? And then just 1 over t here, right? And now we have to actually find what the values are for r prime of t. We have to take the cross product of r prime of t and r double prime of t. With this kind of the way if we leave it with t, it kind of gets a little messy. So I think what I'm gonna do is I'm gonna plug in our t value because we know what our t value is, and we know we want another curvature at that t value. So I'm just gonna plug in the t values here. So r prime of 1 is going to be equal to 2, 1, and 1. Alright, plugging in t equals 1 into here. And we're going to have our double prime of 1 is equal to 2, negative 1, and 1. Right? So now we want to take the cross product of these two vectors, right? And taking the cross product of these two vectors would give you something along the lines of r or equal to 2i minus 4k, right? If you want to take the cross product, you can go ahead and do it yourself. That's fine. You're going to get to the same result that when you take the cross product, r prime and r double prime of 1, you're going to get this. Right? And the problem is asking for us to find the magnitude of it, not just finding what the cross product is. So we want to find the magnitude of this, would take the magnitude of this, r cross r double prime. Right? It's going to be the square root of 2 squared plus negative 4 squared, which in turn would just be equal to the square root of 16 plus 4, 20. There you go. So we found the top, right? Now we want to just we want to find what the magnitude of r prime cubed is, right? And so here, up here, we can go back up here and we can actually find what the magnitude of it is. just by going r prime back to the r prime of 1. Right? It's just going to be equal to the square root of 2 squared plus 1 plus 1, which is then in turn equal to the square root of, that's 4, 5, and 6. Right? So we know what the magnitude of r prime is, and now we were tasked to just cube it. Right? So we're going to have, plugging in everything we know, we're going to have k is equal to root 20 all over root 6 cubed. Right? And you can go ahead and simplify that if you want. I'm just going to leave the answer as that. Simplification is just one little extra step that you can do on your own. That's the answer.